In this video, we will learn how a simple linear regression model can be used to predict scores on a criterion variable of interest. So in an employee selection or hiring system, after finding that a selection tool shows evidence of criterion-related validity, say, for example, based on a statistically significant correlation with the criterion of interest, we are often interested in using applicant scores on the selection tool to predict their future criterion scores. Now, in this case, when I'm referring to a selection tool, you can think of any type of selection procedure or hiring procedure, assessment, etc. And some common examples include an interview, for example, a structured interview that is rated, a personality assessment, a work sample, or a cognitive ability test. Now, in this context, the criterion is some outcome the organization cares about, like job performance or safety performance. Now, job performance could be measured in a number of different ways. For example, job performance could be measured based on supervisors' ratings of employees' job performance, such as those ratings that might appear in a performance appraisal or performance evaluation. Alternatively, we could use a more results-based objective indicator of performance, such as if you're trying to focus on a criterion for the job of a sales position, then you might focus on an indicator like sales revenue generated for job performance. Now, we can use the predicted future criterion scores to inform decisions on which applicant should be extended an offer. In fact, we can estimate what is called a simple linear regression model with a selection tool as the predictor variable and some criterion of interest as our outcome variable in the model. Now, with a simple linear regression model, we have just a single predictor variable and a single outcome variable. And in this case, our predictor variable will be our selection tool, and our outcome variable will be our criterion measure. The regression coefficients that are estimated from such a model, like a simple linear regression model, these are going to include the model intercept, which is the model constant, as well as a regression coefficient that represents the association between the selection tool and the criterion variable. And together, these two coefficients, the model intercept and that regression coefficient associated with the relationship between the selection tool and the criterion variable, they can be used to construct an equation. Now, in the future, this equation can be applied to applicants' scores on the selection tool in order to predict their probable future criterion scores should they be hired. Now, if we stop at this step here, this approach can be classified as what I describe as a predict-ish analytics approach, meaning that we don't go the full 9 yards, so to speak, and actually cross-validate the model where we actually collect criterion scores for our new data, our new applicants, for example, when that comes in. If we do go a step further and cross-validate the model using future criterion scores to evaluate the model's accuracy, then we do move into that realm of predictive analytics, true predictive analytics. So let's work through an example here to illustrate some of these concepts and how we can use a simple linear regression model to predict criterion scores. So let's imagine that we have a selection tool, and our selection tool is a personality test, which I'll abbreviate as PT here. Now let's imagine our criterion of interest is a job performance measure, which I will abbreviate as JP. Now imagine that we collect data, perhaps in the form of a concurrent validation design where we look at current job incumbents, we give them the selection tool that we wish to validate, which is a personality test, and we give them the criterion of interest measure, which is a job performance measure, collect scores on both of those for this sample of people, and then using those data, we can plug them into a simple linear regression model. And in doing so, we are estimating the model such that our personality test is our predictor variable and our criterion variable of job performance is our outcome variable in the model. And once we've estimated that simple linear regression model, we will get estimates of the model parameters. For example, we will get the model intercept, which here you can see represented with the notation b sub 0, which is fairly conventional. So let's imagine just hypothetically that we estimated a model, we plugged in the data from our selection tool and our criterion measure into a simple linear regression model, and that the model intercept b sub 0 was equal to 2.31. The associated p-value here is equal to 0.06. Now, by conventional standards of alpha set to 0.05, this p-value exceeds alpha of 0.05, and therefore we conclude that the model intercept is not statistically significantly different from 0. Typically, that's not of much interest here in this context. What we're more interested in terms of statistical significance is the regression coefficient that represents the association between our selection tool and our criterion variable, which here is the relationship between our personality test and job performance, or in other words, the relationship between our focal predictor variable and our focal outcome variable. And so here we use that notation b sub 1 to represent the first predictor variable in our model, and because this is a simple linear regression model, this is our only predictor variable in the model. Now, here, hypothetically, that regression coefficient is equal to 0.59, and the associated p-value is 0.01. Because this p-value is less than that conventional 0.05 alpha level for statistical significance, we would conclude that this regression coefficient of 0.59 is statistically significantly different from 0. So we can treat it as being statistically different from 0. And given that, and the fact that this is a simple linear regression model that is unstandardized, meaning that the original variables here did not go through any standardization, we can interpret this regression coefficient in the original scaling of our variables. And so, for example, we could make a statement like, for every 1 unit increase on our personality test, job performance increases by 0.59 units. So with our simple linear regression model, we can actually pull these coefficients out, extract them in order to create a simple linear regression equation. And in doing so, we can use the equation to predict future scores on our criterion of interest, which in this case is JP, or job performance. So here are our model coefficients again. So the notation being b sub 0 represents the model intercept, b sub 1 represents the regression coefficient that represents that association in this context between our selection tool predictor variable and our criterion outcome variable in our model. And here you can see within the model parentheses here, I have the name of our personality test, or the abbreviation of PT here, because this is where we could plug into our model actual scores on that personality test. So let's see what this looks like when we put in the actual regression coefficients and estimates from our model. So here you can see we have job performance predicted, which is our criterion, is equal to our model interceptor constant of 2.31 plus 0.59 times scores on our personality test, which is our selection tool. So we can apply some basic math in order to come up with the predicted job performance or criterion scores. So let's look at an example of that. So let's imagine that we have a future applicant, one applicant, and that applicant scores a 4 on our personality test. Now, using that same simple linear regression model equation that I showed you earlier, we can then plug in that applicant's score into our equation, follow basic mathematical orders of operation here, and we can then come up with a predicted score on our criterion variable of job performance here, which in this hypothetical example is 4.67. Now, imagine, if you will, that this applicant's predicted score on the criterion of job performance is the highest of all the applicants. We had other applicants go through this, and then given that, we might decide to extend a job offer to this applicant. Now, you might notice that ranking the predicted criterion scores from highest to lowest will be the same as ranking the selection tool scores from highest to lowest when you have a simple linear regression model with just one predictor variable and one outcome variable. Now, this approach can still be useful, though, if there is a situation where there is a minimally acceptable level of the criterion that an applicant must exceed. So you could imagine a scenario in which the organization would only extend a job offer and hire someone if their predicted job performance, say, exceeded the threshold of 4.5, okay? Whatever that means on that scaling. In this case, this person's score of 4.6 that's predicted for job performance or the criterion in the future does exceed 4.5, and thus they would be eligible for receiving an employment offer. Now, that said, we typically build our models around multiple selection tools because it's very common that we use what are called multi-tool selection systems, meaning that we don't just have a personality test, for example, but we also put the applicants through, say, a structured interview, maybe a cognitive ability test, maybe give them a work sample as well, and we collect scores or data on all of those for the applicants. If that's the case, a simple linear regression model will no longer be appropriate. Instead, to look at all of those selection tools together and how they predict our criterion of interest, we would use a multiple linear regression model, where in this case, multiple linear regression refers to the fact that we have multiple predictor variables in our model, not just one, we have multiple, and still that single outcome or criterion variable of interest. And in applying this type of approach with a multiple linear regression model to predict future criterion scores, we're applying what's called a compensatory approach to making selection decisions, because each regression coefficient for each one of our selection tool variables and its relation with the criterion in that context can be used to weight the scores, the predicted criterion scores for each of our applicants. So this wraps up the video in which I explained how a simple linear regression model can be used to predict future criterion scores for applicants.